What's up, YouTube? It's Dragon here. I'm camped out outside of Buena Vista, Colorado today in mid-February. It's a beautiful 50-degree day. It's a bit windy with some probably 40-mile-per-hour gusts, but it's nothing the solid steel Dragon cabin can't handle. So I wanted to make a video going through the electrical system. So I'll make this a Tiny House Basics video number 3. And so I'll start with the battery system, then I'll go into the solar, and then just run through all the various electrical appliances, 120 volt inverter, lights, gas valves, all that good stuff. So let's jump into it. Actually start under the hood of my car. I've got a dual battery system, and I just recently ran a 10 gauge wire from my deep cycle battery in my car to the deep cycle battery of my trailer, so that when I've got my solar hooked up, it's charging both of them. And this is fused at the positive. It's a 30 amp. Also got a switch so I could pair to my starter battery, parallel it with the other two batteries so that I can always have a reliable way of jumping off my car and keep my starter battery charged up with the solar if I feel like it. So I've just got that set to deep cycle right now. So the car, everything in the car, the radio and everything will work off of the deep cycle as well. Let's hop in here real quick. I'll show you my vehicle's voltage amperage meter. It's got a little hall sensor on the positive wire of coming out of basically the two batteries out of the switch that connects the two batteries under the hood. So that tells me how many amps and how many watts I'm discharging or charging, or going in or out of the batteries. And it also gives me a voltage number, so I know kind of how healthy my starter battery, my deep cycle batteries are. And, you know, if I start the car, then I also get to check out my alternator voltage, which is good right now at 14.2 volts. And I get to see how many amps the alternator is pushing into the battery. So batteries are pretty topped off right now, so they're just kind of getting a float charge of about 17 amps. Don't need to do that too much. Since they're topped off, you know, they're pretty good. So here's where I've connected positive and negative from the deep cycle under the hood. It's running into my hitch box, and I'll just open this up real quick and show you guys what's going on in there. So this is a look inside of my hitch box. I want to get my propane tank out of the way so we can see everything that's going on here. She down there. So positive and negative 10 gauge wire coming through the car from that deep cycle. And it's hooked to my second deep cycle, the trailer deep cycle battery here. I just added this fuse onto this battery because if this wire shorted anywhere on my car, both batteries need to be fused, because if only the other one was fused, then this one could still short out. So you need a fuse at your positive terminal of every battery in your system. And I've just got these jumper cables hooked into my main power poles on my power rack. I'll show you that in a little bit. I've got a 120 amp breaker on there. I should probably move that to this positive pole just to be absolutely safe, because currently these jumper cables could short to the frame of the trailer, which would be bad, so I'd like to prevent that. Let's see, I've got my heater system, so 12 volt hot water circulator pump right here. It's very low amperage. It pumps hot water from my hot water heater here through some radiators in the cabin. And I've got some CPU fans blowing, so it blows hot air from the radiators. That's how I keep my trailer nice and warm in this Colorado winter. This is a thermostat that controls the water temperature. So the thermostat sensor is on the output pipe of the water heater. So let me turn it on real quick and just show you how that works. Alright, so you just saw it click on. See the water temperature there. So basically, it heats the water up from 0 degrees, whatever it is outside, heats it up to about 77 degrees Celsius, and then it shuts off the water heater and turns it back on when the water temperature gets to 60 degrees Celsius. So it's constantly just cycling that hot water. And it's actually 50-50 antifreeze in the system. That's so it doesn't freeze, you know, if the system's off when it's below freezing, it'll burst the pipes, and that would be really bad, so you don't want that to happen. Let's see, I've also got a 12-volt gas valve that controls all the gas that goes into the cabin, and that's controlled by a timer, so we'll jump inside and take a look at that. It's windy, so before I jump inside, I just wanted to show you my solar. It's just 200 watts of solar, but it's enough to keep those 2 batteries topped off on the sunny days. I'll occasionally have to turn my car on for a few minutes to charge them up on cloudy days and snowy days and all that, but otherwise 200 watts works pretty well for this size of system. I'm thinking about eventually maybe getting 3 bigger panels and making a solar awning to cover my window, just to keep it from getting smashed out, you know, by thieves. You never know. So it'd be nice to have a fold down, you know, solar shade that's kind of always tied in to the batteries. That way it would be charging even when I'm on the road or, you know, away from home, or it'd be a little bit more sturdy and stable in the wind than just setting the panels out in the sun. But that works for now. So let's hop inside here. Alright, this is my main electrical kind of hub for my tiny house. So I'll just give you a quick overview of everything. Switchboard, power, voltage, amperage meter, thermostat for the heater system, radio, a negative bus, a positive bus with fuses. I've got a small 200 watt inverter here. I've got a larger 1500 watt inverter stored away for, you know, rainy days. And I've also got a battery charger in here. I kind of just store all my extra electrical stuff in this tote. This is a lithium ion 4S battery, so it's like 16.8 volts peak. I just kind of keep it as a backup. If I'm in here and I start running out of power, I can tie it into the system and keep my stuff running through the night. And I've got a little 50 watt LED projector and a JBL speaker there. Let's keep running through this. So the inverter is tied to this power strip, and then that's tied to the 4 outlets. So I've got one in the kitchen charging my battery packs right now. I've got one over here by the window there, and I've got another one near my bed here. So those are all tied into this power strip, so I can plug that in to shore power if I have it, or just my inverter if I'm doing just basic battery charging stuff. Charging my phone and laptop and all that works great. So Fusebox, this is running to all the lights, fans, heater, everything. Just little automotive fuses there. And a guide to tell you what to replace them with. You don't want to damage your wires. So yeah, those jumper cables from the battery are coming in right here from the Hitch box. You can see the radiator heater is right there. Gets that hot water from the water heater and blows air over it to heat the cabin here. The thermostat controls that whole system, so it shuts it off when it gets to the right temperature, which it just hit it. So it turned everything off, turned off the fans, the pump, and the water heater outside. And let's see. So the jumper cables are coming in here. I've got a few things tied into that. This was the old battery charger cable that comes off of the 7-pin plug that you plug into the trailer for the lights and everything. But mostly, I've got my solar input coming to this junction here. So this is basically my main positive negative spot right here. I've got probably 10 gauge wire coming from my solar charge controller. I've got it blacked out so I could sleep at night because those lights are so bright. And so that, I've got a little amperage meter on the battery output side of that. So that tells me how many amps I'm getting from the solar. And right now I'm getting 7 amps free energy from the sun. So that times the 12 volts is something like 100 watts. So those are older panels, you know, they could be a lot better. I'll get some bigger ones, maybe 285 watts next time I buy solar. But for now, this works pretty well. It keeps the batteries topped off on the sunny days. So from the bus bar, the main positive is going into this 120 amp breaker here. And like I said, I should probably put that on the battery terminal, but for now, you know, it's here. And then I've got a latching relay here. So that's actually the first thing. You can see the key here turns on a little utility light, and it turns on my voltage meter so I can just instantly see what my battery is doing, if it's healthy, if it's charged, how the solar is working. And then this main switch turns everything on or off. So that flips on this latching relay, and it's latching so it doesn't use power while it's on, which is really nice because a solenoid is, you know, they get really hot if you leave them on because they're constantly just cycling power through an inductor. They get super hot, they use a lot of energy. So this is just a super efficient way to have just a main contactor for your whole house. And then in this little utility box, I've got a shunt, which is tied to the amperage meter up there, tied into this. So that shunt changes resistance based on how much current is flowing through it. And then this meter converts that into an amperage value to show you how many amps you're pulling through that main positive wire. So right now I'm only pulling 2 amps, you know, with all the lights and radio and everything on. From the shunt, there's a positive wire, comes up here. I've just kind of got it bolted to another positive wire, and I tied that down so it'll never touch this aluminum chassis because the whole thing's grounded. So, I mean, the whole trailer is grounded. The whole trailer is the negative terminal of the battery, basically. So I don't want any positive wires touching that. And it comes from that bolt to this fuse block. And so the fuse block, basically all these wires are going to these switches then. And so let's go from left to right. This one is the thermostat. So you see that coming on and off. Just the whole thermostat system, shut down power to that. This is the master dimmer for the lights. So you can have them as dim, you know, if it's nighttime, I'll leave them on their super dim setting so my eyes can adjust to the darkness. I haven't put those on the dimmer yet. Those are the kitchen LEDs there. But so I'll leave those on. This light switch controls the 4 lights in the bedroom area. And then this one controls the kitchen light, the vent hood. And then this last one controls the 2 lights in the kitchen, but it also sends power to this timer switch, which this, when I turn this, it activates the gas valve that I showed you on the Hitch. So the gas valve in there is closed until the timer is turned on. It also turns on the vent fan. So it's 2 pretty good safety systems to keep you from getting carbon monoxide poisoning which I've got a little CO detector right here next to the stove. And if I run this gas stove without venting it, then that carbon monoxide detector starts showing me the parts per million. And when it gets up to 70 parts per million, it's at 70 degrees Fahrenheit right now. It's like unheard of in Colorado winter. But so that's got 3 alarms at 70, 130, and 200 parts per million of CO. But if I just run this vent fan, so I just turn the timer on, vent fan comes on. There's also switches right here for the vent light and the vent fan. If I just want to turn the fan off, you know, if I've got the door open, it's a windy day. So then I can turn on my stove with the piezo and run it. I'm not gonna leave that on too long, but the piezo is also tied into that timer switch, and it's kind of complicated. It's this 12-volt wire is going to the gas valve, right? So that's going out to the valve outside. I spliced in a 12-volt to 120-volt adapter, and then I've got 120-volt to 240-volt adapter because the stove is from Britain. And then I've got the plug for the stove, which is a massive 3-prong UK plug. So it's not the most efficient way, but it's just to run the piezo lighters. So that's basically how I'm doing it right now. And when they don't work, you know, I keep a lighter right next to the stove. So it's no big deal if the piezo system goes out. So what else is there? So I covered these 3. This switch controls the power to the radio. Listening to some public radio, classical right now. This one controls the water pump, which is disconnected for the winter, but it's just some wires sitting right down there. And normally I would have a pump, you know, with a water tank. I would pump water into my sink and through my RO filter system. I've actually got it all just packed away in a tote right here for the winter, my RO system with the pump. I've got that switch is for this big fan. So I'll take this and put it in my roof vent, and then it will blow in either direction because it's an inverted plus minus switch. So it basically switches the plus and minus to the 2 terminals of that fan to push air in or out based on what you want at the time. And lastly, I've got this blower. It's just a tiny little computer fan I've got on the floor here. Kind of just put it in when I used to have the battery in here to vent the hydrogen gas from charging, but don't really need it anymore, so I barely ever use it. But there's no point in taking it out. I mean, it can be useful for some things, for heavy gases. You know, heavy gases will sink to the floor, so you can use it to vent that. So, got the main switch. I think we went through all of them. And, yeah, it's a cool little system. You can turn everything off and lock it, take the key, and nobody can turn on your lights without your consent, I guess. Trying to think if there's anything else. Oh yeah, so the speaker, Bose speakers from the 1980s, installed on the ceiling. These are connected to the radio. They sound super good. I think they're made in 1984. So I like them. I just did a little maintenance on them. I had to replace a failed connector behind this little access panel. Another electrical thing, so I've got that projector. I'll set it up on the wall here, and I can project on this projector screen, which is also works as a sunshade right now because it's so bright outside. It's actually getting hot in here, man. It's pretty unusual for wintering at 9,000 feet. But what can you do? It's global warming, I guess. So yeah, that's pretty much all I got for this, I think. I've got just a 12-volt cigarette lighter plug here that I added. It's connected to the same power as the inverter. And you can see the inverter power board. I just kind of mounted to this wooden thing. I actually got it out of an old battery jumper box. You know, like one of the ones with the air compressors and everything built in. I just ripped out the circuit board and said, hey, I can use this. Might as well put it in my camper. So that keeps the lights on. It's a pretty efficient little thing. It's better than breaking out the whole 1500 watt inverter, which is just massive. So, all right, well, that's all I got for now. So you just let me know if I missed anything. If you got any questions or comments, just leave them down below. Make sure to hit that like and subscribe button to keep getting videos like this. This is Tiny House Basics number 3, electrical. And I hope you learned something. And stay creative. Stay, keep adventuring out there. Find your calling in the world and follow it to its end. All right, I'll see you guys next time.